Today's lesson covers section 5-4, which is on multiplying and dividing fractions. One of the biggest things to remember when you multiply and divide fractions is that you do not need a common denominator. What you need to do is multiply across your numerators and multiply across your denominators. However, there is a shortcut that can save you some time if you want to use it so you don't have to simplify later on. For example, if you have a number that is on the top of a fraction that would simplify or cancel with a denominator, you can do that before you multiply. If you look at this first one, if I just multiplied it like normal, it would be 3 times -4, which is -12, all over 8 times 5 on the bottom, which is 40. Then, using those divisibility rules that you learned last unit, you would look at this and say, oh, I can divide this both by 2. And so, you would end up with -6 over 20. And then you would say, oh, they're both even again. I can divide them by 2 again. So you would get -3/10. However, if you would look ahead and cancel within the problem first, you could say that, oh, a 4 on the top and an 8 on the bottom, both can be divided by 4, so this would become -1, and this would become 2. And therefore, your multiplication is 3 times -1, which is -3, and 2 times 5 on the bottom is 10, which is what you already had the first time when you multiplied straight across and had to simplify at the end. The second example I have is 2x over 9 times 3/4. Again, you could just multiply straight across. 2x times 3 gives you 6x, and on the bottom you have 36. Well, you have 6 and 36 as your numerator and denominator, so they can be simplified. You can divide those both by 6, and if you do that, you get 1x, which you don't need the 1, so you would just put x over 6. However, take a look at that problem, and you could have canceled or simplified your 2 and your 4. 2 divided by 2 is 1, and 4 divided by 2 is 2. And then also notice the 3 and the 9. They can be divided by 3, so 9 would become 3, and that would be 1. So if you look at everything on the top, you have 1 times x times 1, and anything times 1 is the number itself, so that would be x, and on the bottom you have 3 times 2, which is 6, which again was the same answer that you did if you multiplied across to begin with. There is a very common mistake that people forget, or that they do when multiplying mixed numbers. What I see some people do is they multiply those whole numbers and get -2, and then they try to multiply these two fractions. Don't do this. This will not work. Like I said, this is a very, very common mistake, and it doesn't work. What you want to do is change these or rewrite them as improper fractions. So if I rewrite these as improper fractions, I take 6 times 2, which is 12, add 5, which is 17. And of course that's negative. So -17/6 times 1 times 5, add the 3 on the top, would be 8/5. You want to take the shortcut and see if there's anything in your numerator or denominators that you could cancel, which you can. Simplify both of these by 2. So then you can multiply across the top and multiply across the bottom. If you do 17 times 4, you get -68, and on the bottom you get 3 times 15, 3 times 5, which is 15. Now you just want to double check and see if you can simplify this, and if you can't, you can go ahead and leave this as an improper fraction. You don't have to rewrite these as mixed numbers anymore. Understanding multiplicative inverse will make your life incredibly easier as you start solving some complex equations. If you know how to cancel out or come up with the number 1 on an equation, it makes your life much, much simpler. So, a multiplicative inverse is the product of a non-zero rational number and this number, and it ends up being 1. So you know that rational numbers are any number that can be written as a fraction. So I'm going to look at the number 5, and I'm going to write it as a fraction. So 5 as a fraction would be 5 over 1. Well, I want to multiply it by something and end up with 1. Well, in order to get 1 with 5 on top of a fraction, I have to have 5 on the bottom of the fraction, because the only way that you can have 5 on the top and cancel that out or divide and get 1 is if it's the same number. So if I need 5 on the top and 5 on the bottom, I would need 1 up on top of this one and 5 on the bottom of this one. Then if I multiplied across, I would get 5 over 5, and 5 over 5 is the same thing as 1. Or if you used the canceling or simplifying method, 5 and 5 would both become 1 and 1, so when you multiply those, you would get 1. I'm going to show you another fraction. Let's say that you have the fraction 2/3. You have to think about what you could multiply this by to end up with 1. Well, the quickest way to get to 1 is to put 3 on the top and 2 on the bottom, because then they cancel each other out, and all of those are 1, and 1 times 1 is 1, and 1 over 1 is 1. So if you notice, multiplicative inverse is simply taking your fraction and flipping it upside down, which in the past you have probably used the word reciprocal. Your multiplicative inverse is the same thing. It's taking a fraction, flipping it upside down. But we don't really want to think about just flipping a fraction upside down. The reason we want to flip it upside down is so that the numerators and the denominators cancel out to equal 1. We really like the number 1 when we are multiplying in math. You may have heard, sometime before, that you can't divide fractions. That simply isn't true. It's just that the reason we don't divide fractions is because division can get a little bit yucky. With multiplication, you can multiply any two numbers together and get, like a decent number. If I were multiplying 2/3 times 1/5, 2 times 1 is no problem, and 3 times 5 is no problem. Both of those are fairly simple numbers. However, if I would look at dividing fractions like that, actually, let me show you. If we divided something like 12/15 divided by 4/5, this works out pretty well. You can divide across the top. 12 divided by 4 is 3, and 15 divided by 5 is 3, which is the same thing as 1. Now, this doesn't work all the time because it's not very often that you get a numerator and a denominator that you can divide evenly and get nice, whole, clean numbers. So, if you look at this problem, the first one, 2/9 divided by 2/5. You could divide across the top, and 2 divided by 2 is 1, but then when you try to do 9 divided by 5, you all of a sudden end up with either a fraction or a decimal, which just ends up making more work at the end anyway. So let me go back and show you the 12/15 divided by 4/5. If I go back to what your elementary teachers told you, they would have told you to keep the first fraction the same, change division to multiplication, and flip your second fraction. Now, with multiplication, it's all neat and clean and easy. We get nice numbers. You could multiply 12 times 5 and get 60, and 15 times 4 and get 60. Or you could use the shortcut and say, oh, I could simplify these, and 4 makes 1, and 12 makes 3. And I could simplify 15 and 5. This makes 3, and this makes 1. Oh, I have 3 on the top and 3 on the bottom, and 1 over 1 is 1, which is the same thing that I... So let me go back and show you 2/9 divided by 2/5. If I tried to do that, dividing across, like I said, 9 divided by 5 would not be pretty, but you know that multiplying is the opposite of dividing, so you can keep your first fraction the same, change division to multiplication, and flip that second fraction upside down, which is also known as the reciprocal or the multiplicative inverse. Therefore, you can continue working just like you would with multiplication. 2's would cancel out to be 1. So on the top, you have 1 times 5, and on the bottom, you have 9 times 1. 5/9 is a number that looks familiar, and it's not a crazy number that you would have had if you tried to divide your fractions. You will work through the same process for fractions, including variables. Hopefully, having those letters in your problems are not as intimidating. Know that you can work with letters or variables just like you do with numbers. So when you divide fractions, you keep your first fraction the same, so 3b over 7. You change division to multiplication, and you flip that second fraction. You want to look for any shortcuts or cancellations with your numerators and denominators. And 7, you could divide both by 7, so they would become 1. And then also you have 3 and 6. You can divide by 3, so this would be 1, and this would be 2. So if you look at everything on the top, you have 1 times b times 1, and 1 times b times 1 is b, and on the bottom you have 1 times 2, which is 2. And you can leave your answer as b over 2. All right, it is time to try some yourself.